Okay, in chapter 9, we looked at one sample and compared it to a population mean. Here, what we're going to do is look at two samples and compare those two samples. Is sample 1 significantly different than sample 2? Is sample 1 significantly more than sample 2? And is sample 1 significantly less than sample 2? All three different ways to do it. Now, what we did in chapter 9 is we took a sample, let's call it sample 1, and we compared it to a population mean. Now we're going to do the same thing with sample 1, just comparing it to sample 2. So sample 2 kind of represents our population mean like it did in the previous chapter. So everything is kind of the same. And you know what's really great about this one is Excel really does a good job of doing the work for you. It actually, in data analysis, you'll see two sample t-test assuming unequal and equal variance. You'll see two sample for z-tests as well. So all we're going to do in this chapter, there's a lot to this chapter, but we're at the end. Let's just focus on two different types of tests. One for the mean where sigma is known and one where it's unknown. Now, guess what? When sigma is known, what are we going to use? We're going to use z. For the sigma unknown, we're going to use t, and that's the only two real differences here. When we compare the two, you see how you got mu1 minus mu2, what we're really doing is seeing if that difference is either greater than 0, less than 0, or equal to, not equal to 0. So the difference between one sample and another. So that's really what we're looking to do in here. So let's get right into an example. The steps to get here are the exact same as chapter 9. Again, the calculation's a little different, but I'm going to show you it in Excel. So let's say we have two different golf balls and we want to compare to see which one goes farther in terms of driving distance. We've got par golf balls and we got wrap limited. And so let's take a look at the data for them. And we've got a sample size of 120 for par, and those went about 275. We're going to call that sample 1. And then we're going to compare that to wrap limited with 80 balls and 258 yards as the sample mean. We have population standard deviations. This is based on their data that they've given to us, let's say, based on their tests. And they've got, for sample 1, it's 15 yards. For sample 2, it is 20. When we look at that and we want to be able to calculate a hypothesis test, let's go to the next one here. We want to compare and say that sample 1, which is par golf balls, represents the population of all balls for par. And then for that sample of 80 golf balls for wrap limited, that represents the population of golf balls for that population. And then let's see what the difference between these two are. You know that 275 minus the 258 is 17, but is that significantly different than 0 is what we really want to find out. So again, we could do a left tail test, which means significantly less. Is sample 1 significantly less than sample 2? And you see on here, that is represented here. So here's sample 1 minus sample 2. Is that significantly less? Is it significantly more in this case? Or are we just looking for difference? And again, that's based on the problem. If the problem says difference or are the two equal, then we're looking at a two-tailed test. If you're looking for more or less than, then you're with the other two types of tests here. So let's do it a little bit different this time. Let's use a significance level of 0.01 and see if the mean driving distance of par ink golf balls is greater than the mean for wrap limited. Okay, so let's look at that and let's think about that as we go up on the board here. And we can say that mu2, the second population, the second sample, is wrap limited. If we put that right here at the middle, is par ink significantly greater than wrap limited? And so that's what we want to look at. The significance level in this case is 0.01. And then we have to know what the z-score would be at this point for the critical value. And we can look at that in terms of calculated, and more importantly, do we have a p-value that is less than 0.01? If we do, then that tells us that their par ink golf balls are drive significantly greater than the wrap limited golf balls. So we did this, again, we're looking to see greater than is what we really care about here. So that means when we take one minus the other, it should be greater than 0. We're specifying 0.01 here. And if we did the hand calculation, it would come out to 6.49 as a computed t-score or z-score. And let's just take a look at that in our Excel here. I think it'd be a lot easier. So how do you do this in Excel? Again, we have videos that show you how to do this, but you go to the Data tab, click on Analysis and Data Analysis. You go to Z-test 2-sample for mean. You're going to have to enter a bunch of stuff in there, including the variances. Now remember, variance is nothing more than standard deviation squared. You're going to put both ranges in there. You're going to put the hypothesis mean as 0. Alpha needs to be 0.01, and that just represents where you're putting it. So again, there are Linda videos that I've put on D2L that show you how to do this. MindTap does a good job of explaining this as well. So the how-to part should be something you can do. And see if you can replicate this. And well, I guess I'll put the data up so you can see that. But if you do, what you see is, first of all, let's look at some of the numbers that make sense to us. First of all, we have our different mean and variances, but what we've got right here is that z-score of 6.48. We've got a one-tail that is extremely small. By the way, that means e to the negative 11 means 0.000, 10 zeros, then 45. So this is what it would look like. That p-value is equal to 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 4, 5. That's your p-value. Is that kind of small? Yeah, I think so. So it is significantly different, which means it's significantly more in this case. Okay. Let's now take a look at when sigma is not known. I think this one's always easier. Again, it's more common that you do not know the population standard deviations. So if we were to look at this in terms of gas mileage for specific motors of Detroit, I like that, being that I'm a Detroit guy, and we want to compare our miles per gallon and see if there's a difference here. We end up with a sample size of 28 cars for the Japanese cars and 24 for the ones from Michigan, that's sample 1, with a sample mean of 29.8 compared to 27.3. Here's your two different sample standard deviations. We do not know the population standard deviations. And if we were to use Excel to come up with this, I think that's the best route. We'll do that, and I'll show you those calculations here in a second. But the same thing here. Now, if we're looking to see if one is greater than or less than, then it'd be a left or a right tail test. But if I were looking for a significant difference, then that's a two-tail test in this case. So we want to conclude based on 0.05 level of significance. We want to see if the performance of M cars is greater than the miles per gallon performance of the J cars. So we are looking at a one-tail test. We're comparing one to the other, and that will get us the same thing. We're looking, again, for greater than. So let me go to the whiteboard, and we'll get it to look the way we want it to. In this case, that's 0.05, and this would be the J car, since that's sample 2. And then where does the M car fall in relation to that? So if we were to do this, again, looking for that, there's your greater than alternate. Put it into Excel, take a look at that. Again, there are videos that can show you how to do that. And putting all of that data in, hit OK. and you find out, first of all, the degrees of freedom is 41. You have a critical t-score of 1.68 for one tail, and that's what we care about. And then we have a t-score, t-stat is calculated t, of 3.99. So let me put that on the bell curve to show you what that represents. That means 1.68 is right here. That's the t critical one tail. And then we'll even draw it a lot longer. 3.99 is way out here, and that's the t-stat that you see there. And then that means that this area is 0.000, 3 zeros when you have an e to the negative 4. 133. So the p-value is definitely less than 0.05. The calculated value is definitely greater than 1.68, or the critical value of t. Therefore, the M cars are significantly higher miles per gallon than the J car in this case. So again, we're at that point where I want you to be able to understand what a p-value shows you, and hopefully this makes a little bit of sense in understanding the difference between two different samples. Is there a significant difference or is there not?